So let's now go over an example of determining these crystallographic directions. So again, this will be on our quiz. So I've given you a drawing with a direction in it, and I want you to determine those indices and write it as a direction, just like I showed you in the previous module. And do that, follow the procedure, pause the video here, see what you get, and put that into your quiz, and then come back and we'll go through this together. I'll show you the steps, and we'll see if we arrive at the same answer. All right, so I've redrawn, sketched it by hand, so if you need, again, a better view of it, go back to the slides so you can see that. But this is our original direction, and we are going to determine the indices for this direction. So again, going through the steps, our first one was to move it if it doesn't go through the origin. Our origin's here, and the initial point's up here, so we need to move it. And so I can either draw a new one, or I can redraw it here. But when I do that, you see that effectively it is angled down, right? And this is 1/2 over here, and it's in this back face. So we are going to basically start here, and then we kind of have to redraw another unit cell down below, and it's going to be about half the position. So we can redraw from the origin over to this point, and this is -1/2. But it's still on the back face, right? This back face of the cell. All right, so that was step one. This is the origin 0, 0, 0. And so now we need to determine our projections. So I'm going to draw that table that I did before. All right, in the x direction, again, it's on that back face of basically the plane of the paper. And so the x is coming out at you, and so it's not projected in the x at all. And so this would be 0, A. All right, the next one, just like we saw in the previous example, this also touches the y-axis, the edge here of the cell. And so that means that it is 1 times the length of b. And then here we get to the last part, the z-axis, the projection of the z-axis. And again, we have here that it's projected in the z-axis, but it's negative. And so it's projected negative 1/2 the length of c. All right, so again, just like we saw in the previous example, we have a fraction. And so we're going to have to multiply as our next step by 2 to get to the smallest integer for this. So we have 0a, 2b, and then this is going to be -1c. So now we've got the smallest integer as possible, and so now we need to encapsulate it with square brackets and put the 0, 2, and 1. However, you might think that we're going to just put -1. Well, that's the next part of the sort of convention here, is that whenever we have a negative in crystallography, we don't just put the minus out in front like you always see a negative. We actually put it on top. So we write a negative like we see here. And so you basically, when you're reading this out, we would read 0, 2, bar 1. So instead of calling it -1, we actually call it bar 1. So that's, again, just part of this notation that crystallography has. And so to be consistent, we always want to make sure we follow it. So negatives have a bar on top, and we read it out as a bar plus the number. So this would be our indices for the direction that was drawn in the slides.